Okay, let's start with factoring a GCF. Well, GCF means the greatest common factor. Okay? So the greatest common factor means that's the number or the variable that can divide out to every piece of the polynomial, or every part of the expression, every term. Okay? So to begin with, we'll just kind of remind ourselves of how we multiply these through. So A, in this case, is the greatest common factor. But if it were multiplied through, it would be 3a squared plus 7a. Okay, so notice the 3a squared plus 7a, if you're looking for the greatest common factor, we don't have a number that divides into 3 and 7. But the variables a squared and a, we can divide out at least, or at most, 1a out of both of those. So that's why here would be the factored form, okay, with the greatest common factor of a written out front. So same thing with this next one. If I multiply it through, I'll have negative 2m to the third minus 12m squared plus 2m. Okay. Now you look at that and you say, okay, between 2, negative 12, and 2, and since this leading coefficient here is negative 2, can I divide out 2 from everything? Or what's the largest number that divides into all three of those numbers? 2, right? We see it because we see the answer to the left here. And since it's negative, we'll see if we'll just divide out a negative as well. So negative 2 can be divided out. Also, you look at the variables. We have m to the third, m squared, and m. Okay, so the largest amount of m's that can divide out in all three of those would just be m to the first. All right, after we divide out 1m, then we wouldn't have any left in this last term here. So we divide out negative 2m. That's my greatest common factor. Okay, so what we're doing today is we're going to start with it already multiplied through, and we're going to come up with to the left. So that's why we're just kind of showing how this works. So let me multiply this one through. So this would be 4x to the fifth y minus 8x to the third y squared. Okay, so looking at the 4x to the fifth here, the numbers 4 and 8, I can divide out of 4. 4 goes into both of those. So I'm going to divide out of 4. Variables, I have x to the fifth and x to the third. Well, how many can be divided out of both of those? Well, you look at the smaller of the exponents, would be x to the third. I can't take more than x to the third out of this one. Okay, so that's what I'm going to take out, 4x to the third. Then I have y's. I have y and y squared. So I can't divide out more than the least amount, which is y. So 4x to the third y is my greatest common factor. And then what's left is what's left. Okay? So factoring is just taking a polynomial and finding out what was multiplied together to get that polynomial. Okay, it's kind of like division. You had the number 8. A couple of the factors for 8 would be like 2 and 4. 2 times 4, when multiplied together, give me 8. Or 1 and 8. Okay? Those would be factors. So when we have a polynomial, we're going to find out what's multiplied together to give me that polynomial. Okay? So if polynomials can't be factored, they're called prime. Okay? And we're going to work on the greatest common factor today and find what can we divide out first before we actually do a little bit more factoring. So we're just going to go just step by step here. So the first step is identifying the greatest common factor. So you look at the numbers first. That's what it's saying. Check the coefficients. So check the numbers. Out of the numbers, are there is there something that can divide out of all those numbers? So back up to where we were, like on these examples, on the second one and the third one, yeah, we divided out a -2 and we divided out a 4. That divided out. Okay, so that's part of it. That's first step. You look at the variables. And it says here, a variable must be present in all the terms. So if they're not x's in all the terms, then you can't divide one out from all the terms. Okay? If a variable is present in all terms, take the one with the smallest exponent, because that is the most that you can divide out of that one. Right? X squared, if that is the lowest exponent out of all the terms of the x's, you can't divide out more than that. So that would be your greatest common factor part of, a variable, the variable part. Then step 2 says divide each term by that greatest common factor that you come up with, and then you leave what's remaining in parentheses. So it looks like these first examples. This, that I'm boxing in right here, this is what it's going to look like. My greatest common factor, parentheses, and then what's left after I've divided everything by this greatest common factor. And then I can check to see if I'm right by multiplying my greatest common factor through and see if it comes up with the original polynomial that I started with. All right, so as we go here, let's keep that in mind. So example 1, you have 3x plus 12. So our first step is you look at the coefficients, or the numbers, 3 and 12. Can I divide anything out of 3 and 12? Or what can be divided from both of those, if anything? 3. So are there variables in both terms here? No. So I'm not dividing anything else out, just 3 then. So if I divide out 3, what's left? Well, the first term, 3x divided by 3, leaves me x, right? And then plus, and go to the next term, 12 divided by 3 is 4. So that's what's left. And if you want to make sure if you're right, multiply the 3 through and see if you get 3x plus 12. And we do. Okay, example 2. Can I divide something out of 8 and 36? Because that's where we start. 2 goes into both of those. Okay, let's start with that. What about m and n? Those are 2 different variables. So can I divide something out? Variable-wise? Can I divide any variables? There's not an m in both of them, and there's not an n in both of them, so no. So what's left? 4m plus, what's 36 divided by 2? 18n. Okay, now I look at my answer and say, can I divide any more? What about 4 and 18? Is there something that divides into 4 and 18? 2. Okay, so if I'm dividing out another 2, I already have a 2 outside. So maybe initially I should have divided by 4 then, right? Isn't 4 divided by both? So let's rewrite it and divide by 4. So 8m divided by 4 would be 2m. 36 divided by 4 would be 9 and the n. Okay. So it's okay if you start with 2 and you see, oh yeah, 2 divides in, but then you look at what you get and see, oh, I could have divided some more. So then you just do it again. And now 4 becomes our greatest common factor. Whereas we thought 2 was, but then we divided it another 2, so if you times those together, it'd be 4. Okay, what about this one? 15 and 18. What goes into both of those? 3 goes into both of those. All right, do I have variables in both terms? Yes. So how many can I divide out of both of them? X to what power? The first, yeah. All right, so what's left? 15x squared, and I divide it by 3x. So 15 divided by 3 is 5. X squared divided by x leaves me how many x's? X to the first. Yep. I had 2 of them, and I divided out 1 of them, so now I'm left with 1 of them. Plus 18 divided by 3, 6. And then the x's would reduce, so I'm just left with 5x plus 6. Then I look at that, and I cannot find a number that divides into both of those, so I think I'm done. Hey, you getting the idea? All right, now these last three, it might get a little multiple items here. So now I have 12, 8, and 6. What divides into all three of those numbers? 2. Okay, anything bigger? Just checking. If 2 does 4? Okay. So all right, now I have x to the 5th, x to the 4th, and x to the 3rd. So how many can we take out of all three terms? Can I take out x to the 5th from all three of those? Can I take out x to the 4th from all three of those? Can I take out x to the 3rd from all three of those? Yes. So we look at the lowest exponent, and that's what we divide out. Okay, now we go and figure out what's left after we divide out by the greatest common factor of 2x to the 3rd. So 12 divided by 2, 6. X to the 5th divided by x to the 3rd. How many x's are left when we divide 3 off? 2. So that's x squared. Now let's see. 8 divided by 2. That would be 4. X to the 4th divided by x to the 3rd leaves me how many? X to the 1st minus 6, which is 6 divided by 2, 3, and then the x to the 3rds divided give me 1, so now I'm left with this. And I look at the numbers 6, 4, and 3, and you're right, I cannot divide that any further. All right, example 5. So let's see, the numbers. I guess it's a 1 in the first term and a 3. So I don't know that I have any numbers that I can divide out other than 1, but that's not going to help us. Okay. So in the first term, I have x's and y's. In the second term, I have x's and y's. So how many x's can I divide out from both terms? X to the 1st. How many y's can I divide out from both terms? Y to the 1st. So xy becomes our greatest common factor. So if I divide then, x squared divided by x leaves me x to the 1st. Y divided by y is 1, so I don't need to write anything there. And then 3 didn't divide out, so I'll have a 3. It looks like the x's and the y's both reduce. So I'm just left with x plus 3. Okay, this last example, it looks kind of long and big, but remember, we'll just take it one number at a time, one variable at a time, and then it'll clear up quite easily. So the numbers, 3, 9, and 15. What divides into all those? 3. 3 does. Okay, so let's divide by 3. What about a cubed, a squared, and a? What can I divide out of all three of those? A to how many? A to the 1st, right? The lowest exponent divides out of all of those. Now the b's, b squared, b cubed, and b to the 4th. So b squared. Let's see, c squared, c cubed, c. All right, so now what's left? Well, the first term, the 3's reduce. A cubed over a, that would reduce to a squared, right? Dividing. B squared reduces to 1. C over C reduces to 1. So I'm just left with a squared. Minus 9 divided by 3. So we'll go to the second term. 9 divided by 3 is 3. A squared divided by a would be a, right? B cubed divided by b squared leaves me b to the 1st. And c squared divided by c leaves me c to the 1st. Okay? Plus, now 15 divided by 3. That'd be 5. And now we have a divided by a reduces to 1. B to the 4th divided by b squared leaves me b squared. C to the 3rd divided by c, c squared. And there it ends. Okay, those are some examples of dividing by the greatest common factor. Okay, so your examples or your questions, they're not going to get as complicated as example 6. Not that many anyway. So remember, start with the numbers, then make sure there's variables in each one, the same variable in each term. And if you have variables, you look for the lowest exponent to divide out that's already in those. All right, give those a try. See how you do.